Hey there, welcome back. I'm Emily Gaddam. The last name rhymes with Adam, and I'm a nurse with a master's degree in health delivery science. I'm a certified infection preventionist, going on 8 years now, and I like to play around with Excel spreadsheets. Yes, that is my idea of a wild Saturday night. In our last video, we ventured into the exciting world of statistical process control, common cause variation, special cause variation, and the basics of an SPC chart. Today, we'll refresh our memories on these concepts, and then we're going to create an SPC chart or lay the groundwork to create an SPC chart using Excel. Because who does not love a good spreadsheet? So grab a drink, maybe a cookie, and no worries about the size or consistency here, and let's crunch some numbers together. All right, let's do a quick refresher on statistical process control. Now, if you've got the memory of a goldfish like me, or if you dozed off during the first video, no judgment here. I know stats are not everybody's cup of tea. You might be wondering, Emily, what's this SPC thing again? Well, Statistical Process Control, or SPC for short, is a quality control method that uses statistical techniques to keep a process running smoothly and to make sure we're creating products that meet our standards with as little waste as possible. SPC is all about understanding variation. There are two types of variation: common cause variation and special cause. Common cause variation is the natural inherent variability within a process, while special cause variation is due to external factors. The magic of SPC lies in being able to tell the difference between these two types of variation. Once we can do that, we can investigate and correct any special cause variations, leading to better processes and higher quality products or services. An SPC chart is a visual tool used to track process data and identify whether variations are due to common or special causes. Now, let's talk about the red and green zones on an SPC chart. The green zone represents the area between the upper control limit, UCL, and the lower control limit, LCL, where the process is considered in control. The red zone, beyond the control limits, indicates that a process is out of control and requires further investigation into potential special causes. Now, before we jump into Excel, let's quickly review some basic statistics concepts. In a normal bell curve, most data points fall near the mean or the average, with fewer points as you move further away. Standard deviations measure the dispersion or the spread of the data points around the mean. In a normal distribution, about 68% of the data points fall within one standard deviation from the mean. So here you see in the green, that's about one standard deviation from the green in either direction. 95% of the data points fall within two standard deviations, and 99.7% fall within three standard deviations. In the context of an SPC chart, the upper limit and the lower control limit are typically set at 3 standard deviations above and below the central line, which is the mean or average of the data. As we mentioned earlier, in a normal distribution, about 99.7% of data points fall within 3 standard deviations from the mean. This means that when your control limits are set at 3 standard deviations away from the central line, you can expect that 99.7% of all data points will fall within the green zone or between the upper control limit and the lower control limit if the process is in control and only affected by common cause variation. On the other hand, if a data point falls outside the control limits in the red zone, it is considered an out of control situation, suggesting that special cause variation might be present. Since only 0.3% of our data points are expected to fall outside 3 standard deviations in a normal distribution, a data in the red zone is a strong indication that an unusual event or factor is impacting the process, warranting further investigation. By setting the control limits at 3 standard deviations, you can effectively monitor your process for stability and detect any special cause variations that require attention. Here, I've just flipped the bell curve on its side so that you can see how the 3 standard deviations above the mean correlates with the upper control limit on the SPC chart, and how the 3 standard deviations below the mean correlates with the lower control limit on your SPC chart. And then the central line is again the average or the mean of the bell curve. Now that we've reviewed these concepts, let's see how to calculate the control limits for our cookie example using Excel. In our cookie size example, we have a data set that represents the average size of cookies in inches for each month of the year. So in column A, we have the month and the year, and in column B, we have the average cookie size in inches. First, calculate the average cookie size, which will be our central line. In Excel, type equals average, and then in parentheses, you can drag from B2 to B13 in an empty cell. Next, calculate the standard deviation using the formula equals STDEV.S, that's your sample. And then in parentheses, you can again drag from B2 to B13 in another empty cell. This is the standard deviation of the sample. So now that we have our one standard deviation, we're just going to go ahead and multiply one standard deviation by 2 to find out what 2 standard deviations is, and by 3 to find out what 3 standard deviations is. Now let's calculate the control limits. For your lower control limit, you're going to select a blank cell and type an equal sign, and then you're going to select the average of your data set. Remember, this average is equivalent to the central line on your SPC chart. And then you're going to subtract your standard deviation times 3 value. For the upper control limit, you're going to go ahead and do the same thing, except in this case, you're going to type your equal sign in a blank cell, select your value for the average of your data set, and then add 3 standard deviation value to this number. And voila, just like that, you've mastered the art of calculating the central line and control limits for your SPC chart. You're now equipped to plot your data points, understand if your process is chilling in the control zone or venturing out into the out of control territory, and investigate any special causes when they pop up. But hey, don't think for a second that we're done. Oh no, we are just getting warmed up. In our upcoming videos, we'll dive into the world of SPC charts even deeper. We'll be looking at how to cherry pick your data for calculating the upper and lower control limits, when it's time to adjust your limits, and we'll even explore other riveting rules of SPC charts. So stick